Hello friends, today I'm going to tell you about matrix or matrices. Well, matrices is the plural of matrix, and since matrix is global to use and can be used in any context, so today we are going to see matrix in linear algebra. Now, matrix is a rectangular arrangement of objects placed in a finite number of rows and columns. Rows are the horizontal lines while columns are the vertical lines. Say if you have something written in between here and this, these are two horizontal lines, and divide this rectangular arrangement into three divisions horizontally, then the number of rows is equal to 3. Now if these two vertical lines are dividing the matrix in three different regions, then we can say these are the columns. Fine. Now objects in a matrix are called as matrix elements. These elements need to be enclosed within rectangular braces. That means these for being represented as a matrix. Now, for any element to be written in a matricular form, we need to write it like 1, 2, 3 in rows and columns. Fine. Now, the product of number of rows to the number of columns give the rank of a matrix. Now, since you can see we have number of rows equal to 3 and number of columns equal to 3, so the rank of our matrix is equal to 3 cross 3. The rank is also termed as the order of matrix. Fine. Now, types of matrices. Since matrix, in a matrix form anything can be represented, so types of matrices are not defined. They will go on varying depending upon what you are taking in consideration. For example, if I talk about physics, then I have a matrix called as poly-spin matrix. Fine. But since we are dealing with linear algebra, we don't need to go to all those things, all those matrices. We have to be specific about those matrices that we are going to use in this particular subject. Now, depending upon what matrix we are going to use in future in this subject, I have listed them, and there are 25 types of matrices that we are going to use in future. Now, row matrix. Matrix having only one row is termed as a row matrix. That means if only this thing existed, it has only one row, it will account or it will qualify for a row matrix. Fine. Now, a column matrix. Matrix having only one column is termed as a row matrix. For instance, if I have elements as this, we have only one column here, and then I can say that this matrix is a column matrix as it is having number of rows equal to 3 and number of columns equal to 1. So this is a column matrix. Now, a square matrix. A square matrix is a one in which the number of rows and the number of columns are same. That means, say if we have 2, if we have 1, if we have 4, if we have 5. These are the elements of a matrix. Then since number of elements, number of rows and number of columns are same, we say this is a square matrix and its rank is like 2 cross 2 or 3 cross 2 or whatsoever. Fine. Comparable matrix. Comparable matrices are those which have same order. That means same rank. If I'll have a matrix of the order of 2 cross 2, then I'll have another matrix of order of 2 cross 2. It will be comparable. Fine. Now, real matrix. Real matrix is a matrix with its elements real. Fine. If I have a matrix, like I have given you example previously, in which I just wrote real numbers, then all those matrices were real matrix. Complex matrix. Complex matrix is a matrix in which the elements are complex. For example, if I have 2 eta plus 5 as one of the element, 2 eta minus 5 as another element, 2 eta minus 7 as third element, and 2 eta plus 8 as fourth element, then that 2 cross 2 matrix will be termed as a complex matrix. Null matrix. Null matrix is a matrix with each element equal to 0. Diagonal matrix. Diagonal matrix is a matrix in which the main diagonal elements are non-zero and rest of the elements are 0. Now what do you mean by main diagonal elements? If I have a matrix like this and the elements written in these places, that at AI, where AI is equal to AJ, fine, where I is equal to J, where I equal to J, fine, position is given like IJ to every of the element present inside a matrix, and this position, and this position qualifies for I equal to J. When these elements are non-zero and the rest of the elements where I is not equal to J are 0, that matrix is termed as a diagonal matrix. Now what do we mean by a scalar matrix? A scalar matrix is a matrix in which the main diagonal elements are equal. That means if I have 1 here, I'll be having 1 here, and I'll be having 1 here. If I have 2 here, I'll be having 2 here, and I'll be having 2 here. Now identity matrix. Identity matrix is a matrix with main diagonal elements equal to 1. That means if I will have 1 here, I will have 1 here, I will have 1 here, then only we can term that matrix, that particular matrix, as an identity matrix. Now moving forward, upper triangular matrix. Since we now know what the main diagonal elements are, that means where I is equal to J, the elements with the position of I equal to J. Now when the elements below the main diagonal elements are 0, it's termed as the upper triangular matrix. And when the elements above the main diagonal elements are 0, it's termed as the lower diagonal elements. Lower triangular matrix. Now, what about triangular matrix? Is one which is either lower triangular matrix or upper triangular matrix. Now, there's a difference between triangular matrix and diagonal matrix. Triangular matrix is either a lower triangular or an upper triangular, but in diagonal matrix what we have the leading diagonal elements as non-zero and rest equal to 0, right? Singular matrix is a matrix with determinant 1. Idempotent matrix is a matrix which one multiplied to itself does not change. Say for example, I take an example. Sorry for making it a bit more complex, but it's not in real. Actually, I will show you how to matrix multiply in further videos. But here, talking about idempotent matrix, say for example we have a matrix 4 minus 1, 12 minus 3, and then it is multiplied to itself, it will give this matrix. If we subtract 16 minus 12, it will give you 4. If we do minus 4 minus 3, it will give us it's plus here. It's plus here. Minus 3 minus 4 will give us minus 1. And if we see this thing, it will give us 12, and here it will give us minus 3. Fine. So how matrix multiplication is done, I will show you in future videos. So for now, you remember idempotent matrix is the one which is multiplied to itself, does not change. That means A cross A gives you A. Fine. Now, nilpotent matrix. Nilpotent matrix is a matrix which when multiplied to itself gives a null matrix. No need to think too complex. If you have a zero matrix and you multiply to itself, it will surely give you a null matrix. Fine. Involuntary matrix. Involuntary matrix is a matrix which when multiplied to itself gives the identity matrix. For instance, I have taken this matrix 4 minus 1, 15 and minus 4, and if I multiply this, we'll get 16 minus 15 minus 4 plus 4, and if you solve this, 16 minus 15 is 4, again minus 4 plus 4 is equal to 0, but I'll just look if yes, minus 4 plus 4 is equal to 0, and 60 minus 60 is equal to 0, 2, and minus 15 plus 16 is equal to 1. That means matrix which when multiplied to itself gives the identity matrix. Now, transpose matrix. Matrix obtained by interchanging the rows and the columns of a given matrix is termed as the transpose of the matrix. Say for example, I have a matrix. 1, 2, 3, 4, and I name it as a matrix A. Now A transpose, represented by A with superscript T here. A transpose is a matrix interchanging the rows into columns. So 1, 2 will get columnized and it will be like this. 3, 4 will be written as this. Now this AT is the transpose of matrix A. That means this. Now transpose of a matrix is a matrix obtained by interchanging the rows into the columns. Fine. Symmetric matrix. Now when a matrix which is equal to its own transpose, that means if I'll be having here 2 and this equal to 1, and then if I'll change the rows into columns, the matrix will be same. The transpose of that will be same. Fine. At that point it would be 2, 1. Transpose will be same as matrix given. Now skew-symmetric matrix is a matrix equal to additive inverse of its own transpose. That means A will be equal to minus of A T. Additive inverses have a property: when they get added, they give you a zero matrix. Fine. Conjugate matrix. Matrix obtained by replacing the elements of its complex elements by their corresponding conjugate. What actually conjugate means, if for example I have 2i minus 5, the conjugate of this element will be 2i plus 5, and the matrix obtained by replacing the elements of its its complex elements by their corresponding conjugates, we get a conjugate matrix. Now what do we mean by conjugate matrix? The transpose of the conjugate matrix obtained is termed as the conjugate. Hermitian matrix. Hermitian matrix is a matrix which is equal to its own transpose. Skew Hermitian matrix is a matrix that is equal to the additive inverse of its own conjugate. Well, I have made you understand what actually conjugate, transpose and conjugate means, so I don't feel there's a need to show you any example of this. Now, orthogonal matrix. Orthogonal matrix is a matrix which when multiplied to its transpose gives an identity matrix. And unitary matrix. Unitary matrix is a matrix which when multiplied to its conjugate. Now you need to have an eye about on this. Matrix multiplied to its transpose giving identity matrix is termed as orthogonal matrix, whereas the matrix multiplied to its conjugate that gives identity matrix is termed as a unity matrix. That's all. Thank you so much. Stay connected.